So now let's talk about rationalization. Rationalization is a method to evaluate a limit at a certain point when substituting in and factoring doesn't work. So whenever I see a limit problem and it asks me to evaluate it at a certain point, the first thing, I have this little guide to what I should do next. So the first thing I try to do is I substitute in. So what that means is I basically just take this number and anytime I see an x, I put it in there. So let's try that out. Limit as x approaches 9, square root of 9 minus 3 over 9 minus 9. And you see the problem with that is we end up getting 0 over 0. And 0 over 0 is an indefinite form. That means it doesn't exist. You can't have 0 over 0. So whenever you substitute in and you end up with an indefinite term like 0 over 0 or infinity over infinity, you know that you can do something else to this original expression so that you won't end up with 0 over 0. That's a very key term to remember. So the second step that I normally like to do is I try to factor anything out. Factor out. So in this case, I mean, there's really nothing I could factor out. If it had been something like x squared minus 9 over x plus 3 times x, I could factor out an x plus 3 from x squared minus 9 and cancel it with the bottom. But here, it's not going to work. So my third and final, I suppose, thing that you could do is rationalization. That's what happens when you look at a word and then you say something different and it's bad. Anyway, rationalization. So you normally do this anytime you see a square root. And looky here, we have a square root. So what rationalization basically is that you multiply the numerator and the denominator by the conjugate of the numerator. So the conjugate is basically just the first term, if it's in terms of x, over here, and then if this is a minus sign, you turn it to a plus sign, and if this was a plus sign, you turn it to a minus sign. So it's like the negative form of that. So you multiply both sides. Let me just have a little square here. Square root of x minus 3, square root of x plus 3, square root of x times square root of x, that's x. This is 3 root x. This will be negative 3 root x. And this will be negative 9. So I notice here that when you multiply 3 times square root of x and negative 3 times square root of x, these two are going to cancel out because you're just going to subtract it. So we end up getting x minus 9. So that's our denominator, or our numerator. And for the denominator, I recommend that you don't multiply it across because you have different powers here, and it's going to be something messy, and stuff is going to cancel. So just stay put for a second. Right? Okay. And then we have square root of x plus 3. So we have an x minus 9 on both the numerator and the denominator. So let's cancel those out. Now we're left with 1 over square root of x plus 3. And you see now, if you plug in 9, you're going to get a definite form. You're not going to get 0 over 0 again. So let's plug it in. Limit as x approaches 9, 1 over the square root of 9 plus 3. Square root of 9 is 3. 3 plus 3 is 6. So this is 1 over 6. And that's how you use rationalization to evaluate the limit at a certain point.